Lesson 2.07, Compound Statements Part 2. Please don't forget to add your course and section number with all communication with me. A lot of objectives today, huh? Looky here, all we got to do is prove statements indirectly. Easier said than done, I bet. Okay, these are some of the words that we use whenever we're proving them indirectly. Contradiction, a statement that disagrees with another statement and can be used to prove that an assumption is false. And what we're going to be doing is the indirect proof, and it's a type of proof in which the first step is to assume the opposite of what is to be proven, also called proof by contradiction. And then we have proof by contradiction, and we have the counterexample. This was just a same review over conditional statements, hypothesis after if, conclusion after then. Converse is flipping the hypothesis and conclusion. Inverse is negating the hypothesis and conclusion. And contrapositive is doing both of those, switching and negating. And this kind of goes over the variables again, that P is the hypothesis, Q is the conclusion. The arrow means imply, and the little tilde mark means not. And here's the tables again. Remember, each table, the first two columns are the same. This is the conditional, the converse, inverse, and contrapositive. And again, these slides will be in doc sharing, so you can go through and review these at your own pace. So let's talk about indirect proofs. The first thing you're going to do with an indirect proof is start by assuming the opposite of what we're trying to prove. We're going to use deductive reasoning to reach a contradiction. And remember, a contradiction is a statement that disagrees with another statement. The contradiction can contradict either the given, a definition, a postulate, a theorem, or any known fact. Indirect proof is also known as proof by contradiction. 4 steps for proving a statement indirectly. You got to have your conjecture, your assumption, your contradiction, and your conclusion. An indirect proof is sometimes written out as a single paragraph instead of a series of steps. Now, indirect proofs, we'll do them in this lesson. We won't do them again. We just won't do them because 2-column proofs are easier to organize and understand. Okay, here's our given. We have triangle ABC. We're going to prove a triangle cannot have 2 right angles. Okay, it's just not possible. That's what we're going to prove. So here's our indirect proof. The first sentence in our paragraph is we're going to assume ABC has 2 right angles, which is angle B and angle C. Alright, so that's kind of our contradiction, isn't it? Because if we're proving it can't have it, it's a contradiction to say that it can. Alright, so here's our next sentence. Because the measures of the angles of a triangle always sum to 180 degrees, the measure of angle A plus the measure of angle B plus the measure of angle C have to equal 180 degrees. I think y'all are all pretty well learned in that department. Y'all know that triangle is supposed to have 180 degrees, and that's the sum of all the angles. Our next sentence says, because a right angle measures 90 degrees, substitute 90 degrees for the measure of angle B and the measure of angle C. So, the measure of angle A plus 90 degrees plus 90 degrees is going to equal 180 degrees. Let's see what our next sentence shows us. Simplifying the left side results in the measure of angle A plus 180 degrees equals 180 degrees. So when they said they simplified the left side, that just meant they were adding the 90s together to get you 180. So solving for the measure of angle A gives the measure of angle A equaling 0 degrees. But if this is true, then segment AB would lie on top of segment AC. And the figure would not be a triangle. See, if this angle A right here was to equal 0 degrees, I'll show you here. Let's look. And let me make it thicker so we'll be able to see it. There's angle A. Well, if segment AB, well, if angle A equaled 0 degrees, that means line AB and AC would actually be the same line because it would be 0 degrees. All right, the next, this contradicts the given information. Okay, here's your given information. Oh, let me get my pointer so you can see where I'm at. Triangle ABC. Well, this last statement saying the measure of angle A would be 0 degrees and that the segments would lie on top of each other, that contradicts the given information that says triangle ABC. So my conclusion, the assumption that a triangle has two right angles is false. Therefore, a triangle cannot have two right angles. So there you go with an indirect proof. So let's look at some examples. It says to prove each statement by contradiction, do the following. Assume the conclusion is false and write the negated assumption. Remember, negate is just the opposite. Show that the negated assumption leads to a contradiction, and then make a valid conclusion about the original statement. So you say, if a quadrilateral is a square, then the quadrilateral is a rectangle. So here's part A. Assume the conclusion is false and write the negated assumption. So it says the quadrilateral is a rectangle. So when we're supposed to write a negated assumption, which means the opposite, so if the quadrilateral is a rectangle, then we're going to write, assume the quadrilateral is not a rectangle. See, we're negating it. Part B says, show the negated assumption leads to a contradiction. The quadrilateral will not have four right angles. Right? If it's not a rectangle, then it's not going to have four right angles. A square has four right angles. Okay, you recall that? So this is a contradiction. Alright, so let's look back. If a quadrilateral is a square, then the quadrilateral is a rectangle. That's true. Assume the quadrilateral is not a rectangle. If it's not a rectangle, it's not going to have four right angles. So that makes it a contradiction because a square has four right angles. C says, make a valid conclusion about the original statement. If a quadrilateral is a square, then the quadrilateral is a rectangle. That's a valid conclusion right there. Okay, provide a counterexample that disproves each statement. It says if x squared equals 36, then x equals 6. So if I was going to write a counterexample, this is how it would look. The value of x could be -6 because -6 squared equals 36, right? If I had 6 squared, it's going to equal 36, but that's not the only answer x could be. X could also be -6. If a number is an integer, then it is a whole number. Ooh, I like this one. We're going to write a counterexample, and here's what it's going to look like. And this is just a sample answer. The number -2 is an integer, but it is not a whole number. Remember, your whole numbers go from 0 to infinity in the positive direction. Whole numbers do not include the negatives. Integers include all of the negative numbers and positive numbers. So this is your contradiction, or your counterexample, that the negative 2 is an integer, but it is not a whole number. What did we learn in this lesson? That indirect proof and counterexamples are very powerful tools for proofs. In an indirect proof, you begin by assuming your conjecture is false, and then you show that this leads to a contradiction. And then no matter how many examples you find for a conjecture, you have not proven the conjecture. On the other hand, if you can find a single counterexample for a conjecture, then you have proven it false. After you get finished with this video, you should read through the LMS Lesson 2.07, complete the student guide, also peruse pages 43 through 45 in your reference guide. And finally, go ahead and complete some practice problems, number 33 and 35 through 41 odd. And after you complete these problems, if you have any questions, please contact me for help before you complete the quiz. And that's going to be it for this lesson. And